Hello, my name is Henry Luong,
Hi, my name is Yongwei Fu. Yeah.
and our project for MSE 611 is the Robotic Bartender. The next slide. All right, so our table of contents, we have the introduction, the Robotic Bartender, the flow chart, electronic connections, the mechanical constructions, the programming, bill of materials, future improvement, and then the conclusion. Next slide. So we're just going to play a video here. This is a demonstration of the whole system. So we have a GUI that controls the whole system. This is through Python. We start off by pressing start cycle. And what this does is this whole machine is controlled by an Arduino, and the Python is communicating to the Arduino through serial port. So the first step, as you see here, the robot grabs the shot glass. It uses a pneumatic gripper. So it places here, it releases it. There's a sensor that detects if the shot glass is there. If it's not there, then it stops the entire sequence. But if it is, as you see here, it's moving. It presents it to the liquid solenoid and where it dispenses the fluid. Here's another perspective. Here we're just adding water. Then now the next step is the cup moves back and the robot picks it up again and it moves it back to the original position. And then it presents the cup to you. Okay, next slide. All right, so the main components for our system includes a 3 degree of freedom robot, a conveyor belt, 2 ultrasonic sensors, a liquid dispenser or a liquid solenoid that dispenses the fluid, and a shot glass. And the robot contains 3 servo motors that controls the movement, and the conveyor belt is driven by a stepper motor. And the stepper motor is controlled by a stepper motor driver, and all of this is controlled by Arduino. And also we have a pneumatic solenoid or pneumatic gripper that's actuated by a pneumatic solenoid, and we had to use a solid state relay because the solenoid takes 24 volts, but the Arduino only has 5 volts. But the servo motors, we were able to directly power it through the Arduino. So next slide.
Oh, yes. I will introduce the flow charts just step by step. So we clone the yellow one, that is the car starts at the platform, and then the ultrasonic sensor will detect and to make detect the cup to make sure the yes or not, and then if yes, they will go to the robot pick up the cup and place it on the conveyor. So and then the next step, the conveyor will move and positions cup to do water dispense and go to the water dispenses. They will add water to the cup, and the conveyor will move cup back to back for robot and go back to that position. The ultrasonic sensor will detect the cups to make sure yes or not. If yes, the robot move the cup to position to grape cup, and the the gripper will actuate it. The next step, the robot will move to the stop position. The pneumatic gripper will release cup, and on the cup platform, there is the ultrasonic sensor that will detect the cup to make sure yes or no. And if yes, that's the final step. The robot will move away cup. Yes, that's for our flowchart. So this part for the electronic connections. So I will introduce the breadboard diagrams. So all these will based on the flowchart, and we use the software that's the freezing. So yes, this software is very powerful to design and build the electric circuits. So we firstly firstly the breadboard diagram was built, and then the wiring schematic will be automatic generated in the freezing. It was very convenient for the section. So I'll go to the next slide. This is for our wire schematic. This one just getting the wire. We just get the wiring schematic in the freezing after finish the breadboard. Yeah, so everyone can see the pictures. But in this part, there are some problems when the wiring schematics was designed in this software, because the actual electric parts that were used in the final project could not be found in this software. Therefore, we use the same functional electric parts from the software library to finish the electric circuits. For example, in here, this one is should be the ST 330 step motor driver. We can find this part in the software, so we use the same functions to replace our design. So yes.
So for the robot, in terms of its mechanical construction, it's a 3 degree of freedom robot. It uses 3 MG995 servo motors, and the entire robot was 3D printed. It also has the pneumatic gripper, as we mentioned, and we also printed the end effector, and we had issues with the servo motors where it broke, and so we had to fix that, which caused some delay. One improvement that we made in the middle of the project was shortening the arm for the so-called second axis. Um, it used to be a lot longer, and then that created a lot of torque on the servo, which apparently damaged it. And so that all the servos were swapped, so that the first axis, we repaired it, and then it now installed it into the first axis, which sees the least amount of torque, and that seemed to work pretty well for us. Okay, next slide. Okay, and the robot was designed in SolidWorks and then 3D printed on an Airwolf 3D printer. Okay, next slide.
Yes, so this part is for the construction of the handwork conveyor. So the wood handwork conveyor was made of the base wood sheets, and each sheet was used as glue to combine and screw to fastening, because the conveyor belt could not find a white one for the conveyor. I searched, I checked there on the Amazons. So so this is a big problem for the project. So finally we using the four timing rubber belt for for 3D printer to replace the wide conveyor belt. So there is the so okay, we can go to the next slide. So here is the wooden mobile platforms on the top of the conveyor because it will be convenient to put down the glass cup with the lobo arm. So the step model okay, not knowing these pictures, the last pictures, the step model run the bearing to run to turn the conveyor belt, and the step model connects the step model driver, and the driver get the signal from the Arduino board, so we can see the ultrasonic sensor and liquid wave will work together with the wood conveyor to move the cup to get the water and come back. Yes. Oh yeah. So this one is for our the cup platform. So the cup platform is the first workstation for the whole program. So the ultrasonic sensor will detect whether the cup is on the top or not. If it is there, it will send a signal to the Arduino board to control the robot arm to pick up the glass cup onto the conveyor. So the cup platform was designed in the SolidWorks and built by the 3D printer. So okay, yeah, I think.
Yeah, and one more thing to add is that this platform came in handy because the 3 degree of freedom robot has a limit of how far it can go down, and this raises the cup to be level or almost level to the base of the robot, so that it can actually reach it. So it served multiple purposes. Okay, Frank, you can go ahead.
Okay, on the next slide.
All right, so we're going to talk about the Arduino programming. The main things to program was the servo motors. We used the servo.h library, including the 3 methods servo.attach, which establishes which pin on the Arduino board you're using it for to send the signal to the servo. Servo.write, which sends what angle do you want to change to set the servo to, and then servo.read, which reads its current position, because with a servo motor, it knows its position. It's a closed loop control system where it knows exactly where it's at. The stepper motor programming, we use a stepper motor for the conveyor, and so to drive the stepper motor, we use a stepper motor driver. And in terms of the Arduino, we send the steps and the direction signal to the driver, and to do that, it's a digital write, high or low, with a microsecond delay within a for loop that tells you to move the stepper motor. You either set the direction high or low for clockwise or counterclockwise, and you can control the speed by decreasing or increasing that delay, and you can establish the distance by that for loop by setting the limit for the for loop. We have to control the ultrasonic sensor. The way it works is it sends an ultrasonic pulse, and then it waits for the echo to bounce out, and it times it and calculates the distance based on that time. And then finally, we use a switch case as a so-called menu. For instance, we use J for rotating the first axis clockwise, and L for counterclockwise, and then L for the second axis clockwise, and K for counterclockwise, and so on. Next slide. Additionally, we created a GUI, which was written in Python using Qt Creator. we have here on the left side, most of the buttons are for jog, the manual mode, and the main button is the start cycle, which runs the entire cycle for the robot that you saw, the sequence. And then very important for us was the home button, which moves the robot in an upright position, as you see there. Uh, and that relieves a lot of stress. It's any other position creates more torque on the robot, and we're worried about damaging the servo. And to communicate between the Arduino and Python, we use the Pi serial library. We had trouble so we were able to communicate from Python to the Arduino, but we had trouble doing the reverse, where because we wanted to use a sensor um, and have it display the status on the GUI, but we still use the sensor, but we just weren't able to establish show the status. It was supposed to be green for if the cup's there, or red when it's not there. Next slide.
Oh yes. So this is the build of the materials. So we show the all components for this project. There are many sensors and devices and some machines like such as the uh, air pressure machine something. So we show their each component the numbers and the price for each component. So we finally we get the total price in here. So the price uh, yeah, the price is here, the 161.04. Yeah, this is our view of the materials.
Okay, so future improvements, as we mentioned, is the communication from the Python GUI to the Arduino. We had an issue of transmitting from the Arduino to the GUI. Yeah, the robot design could be improved so that the servos don't get damaged as it moves. We really had to pay attention to the speed of the servo as well, because by default it goes to the max speed, which caused a few issues. We are just dislocated the arm from the servo. We wanted to incorporate a vision system originally so that it detects if the cup is filled. And lastly, we were originally planning to create a basketball game as a tribute to Kobe Bryant, where it uses a laser and photo sensor. Again, we had issues with the communication from Arduino to Python, so that caused an interruption there. And that was supposed to be, it was supposed to work so that you make 8 points, and then as a reward you get the shot. So you make a shot, you get a shot. Next slide. And in conclusion, this project was a great learning experience for making a complete automated system. Incorporated mechanical design. We did design our own robot. We designed our own conveyor belt. Um, incorporated or included an electrical circuit with various components: a stepper motor, driver, servo, solid state relay, and sensors, and solenoids. And lastly, it included programming in the Arduino C language and Python. And next slide.
Okay, I just want to remind one key point because in the material of the build of the material, I made a little bit mistakes. So the total price should be the $412.64 dollars. No 161. Yeah, just $412.64 for our total price.
Okay, and that concludes our presentation. Thank you.
Thank you.